Hello, everyone, and welcome back to Nunley Math. I'm your host, Aaron Nunley. Thank you so much for joining me here today as we begin a brand new unit on ratios, rates, unit rates, and proportions. Now, this is a fairly extensive unit. We're actually going to have a very long series of videos that really dives into this topic very, very deeply, and then we're going to transition over into a separate unit on percents and how we can use what we learn about ratios, rates, and unit rates to work with percents as well. This is actually one of those really, really important units in pre-algebra because it connects to so many other topics. It reaches back into some of our number sense understandings about fractions and decimals. We already mentioned that it connects to percentages, but it also leads into some ideas that are very, very important with linear algebra as well. So a lot of really important and valuable information in this particular set of videos. Now, not all the videos are going to be terribly long, but this first one's going to be just a bit lengthy because we do have a lot of groundwork to lay. Hopefully the ideas that we present here are not going to be overly complex, but it is very important that we have a real solid foundation, real solid grounding of understanding as we enter this unit. So let's go ahead and dive in and get started right away. As I have mentioned before in others of my lessons, these lessons are primarily designed for students in my own personal classroom. So what you're receiving here is the same lesson or lecture that we would have in my classroom. So it should be pretty thorough and pretty complete. Here we go. Ratios. A ratio is a comparison of two like quantities using division. Notice the word like is both in parentheses, it is also bolded. This is going to be very important for us, so keep an eye on that and make sure you keep that in mind. Ratios can be written as fractions, with a colon, or with the word to, T-O, and any situation can give a rise to lots of relationships. So, for example, I live in the Cincinnati area, so I have two football team logos here, the Indianapolis Colts horseshoe, as well as the Cincinnati Bengals Bengal tiger. And if I wanted to compare these two things, notice that I have four Colts logos, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6 Cincinnati Bengals logos. Suppose I ask you to give me a ratio in simplest form that compares the relationship of Bengals logos to Colts logos. I'm asking you to compare the Bengals to the Colts. Well, notice we said that we have 6 Bengals logos and 4 Colts logos. So if I wanted to write this as a ratio, I would say let's look at this as division. Bengals compared to Colts. Or in the case of this example, there are 6 Bengals when compared to 4 Colts. Notice we get the ratio 6 to 4, or 6 with a division bar 4. You could also write this as 6 colon 4, but we don't do that nearly as often. We find that for most instances in pre-algebra and algebra 1, it's most helpful to have these written in fraction form. Notice over here I also wrote it with the word to. Couple things I want to make sure I point out, and that is this. Since we wrote the word Bengals first, I'm asking you to compare the Bengals to the Colts. Bengals becomes the numerator. Whatever's first in your ratio becomes your numerator, or in this case 6. Whatever comes second in your ratio is your denominator and becomes, in this case, the 4. Now, it is important to make a note that ratio should always be given in simplest form. When necessary, we use improper fractions and not mixed numbers. So if I wanted to have the ratio 6 to 4 in simplest form, that would of course be 3 halves. Now, if you're having trouble simplifying 6/4 to 3 halves, I will show you a method you can use that might make that a little easier for you. If you're having trouble with a fraction that's this small, probably you're going to want to go back and watch one of our videos on simplifying fractions before continuing this video. But suppose I asked you to give me the ratio of Colts to Bengals. Notice that in this case, the Colts are listed first and the Bengals are listed second. That means that Colts will be my numerator, Bengals will be my denominator, giving me 4 to 6, or in simplest form, the ratio 2 to 3. Every time we have 2 Colts logos, we have 3 Bengals logos. And in fact, I could actually draw a circle around these. I think I'll do that for you, where I say, okay, these 2 match to these 3, and these 2 match to these 3. every time you have 2 Colts logos, you have 3 Bengals logos that correspond. I'm going to erase those for you. Here's one for you. What if I ask you to compare Bengals to mascots? Remember, both of these symbols represents the mascot for each of those teams. So when I say Bengals to mascots, notice Bengals becomes my numerator, mascots becomes my denominator, and I get the ratio 6 to 10. There are 6 Bengals logos compared to 10 total logos. 6 to 10 or 3 to 5. Now, sometimes when we do this this way, where we're doing a part compared to a total, instead of using the word to, we use the word out of. So there are 6 Bengals mascot logos, Bengals logos out of 10 total. So sometimes you'll hear the word out of when your denominator is a total. Could you do mascots to Colts? Hopefully you realize mascots is on top, Colts is on bottom. So 10 to 4 or 5 halves. Or how about mascots to Bengals? You may want to pause the video and try this one on your own. And then restart the video. I'm going to assume you've already done that. Mascots to Bengals would be 10 to 6 or 5 to 3. And lastly, again, pausing the video and trying Colts to mascots on your own. Hopefully you've already done that and you find that Colts to mascots would be 4 to 10 or 2/5. Now, this was a pretty long and tedious process, but it's important for us to remember that this situation gave rise to 6 different comparisons. I gave you one seemingly simple relationship, Colts to Bengals, and I was able to come up with 6 different answers depending on which relationship I asked you about. And that's going to be really important for us because it's important in word problems to understand within the context of the problem which of these relationships we might actually be discussing. And once we know which relationship we're discussing, the fractional portion becomes a whole lot easier. Let me go back and refer to one more thing. The word like says that our comparison must be things that are like items. Notice that Colts and Bengals, while not exactly the same logos, are both mascots. They're both mascot logos or symbols. So we would consider those to be like units. Does that help? How about this one? An animal shelter is currently housing 20 dogs, 30 cats, and 25 exotic animals. Please, Disney, don't sue me for putting those in here. They just seem like fun little illustrations. Find the ratio of dogs to exotic animals in simplest form. Now, this is a really good example of an application problem or word problem where we have to explore the information given and we have to determine what we are being asked to compare because there are lots and lots of different relationships that exist within these numbers. The way I do that is I look here and it says, find the ratio of dogs to exotics. Dogs to exotics. Right there is the ratio that we should be writing. Dogs to exotics, so dogs over exotics. Notice we are not asked about the cats at all. The cats have nothing to do with the problem. They're just extra information that's given to us. So if I asked you to give the ratio of dogs to exotics, you would look and say, oh, well, there are 20 dogs and 25 exotics. So your ratio is 20 animals to 25 animals. Notice that even though dogs and, I guess, what is that, a gecko? Dogs and geckos are different animals. We would consider those to be like units because they are both animals. And then, of course, we would write this in simplest form. If you are somebody who struggles to write fractions in simplest form, I would suggest to you that you may find it easier if you take your composite number 20 and break it down to its primes. 2 times 2 is 4, times 5 is 20. And 25 is just 5 times 5. Because if you will take the time to break that down into its primes, you can just look at your numerator and denominator and look for things that are alike. For example, 5 over 5. 5 over 5 is an example of the number 1. We can simplify any like values into ones using the identity property. Now, we don't have time to get into the identity property today. Hopefully you remember that back from our number sense unit, but just keep in mind that anything that's over itself can simplify into a 1 and go away. Same thing with the units. Since we have animals over animals, that can go away as well, leaving us with 2 times 2 on top, which is 4, and 5 on bottom, or the ratio 4/5. Now, a lot of you probably were able to look at 20 over 25 and come up with 4/5 without doing all this. Certainly that is the way I would prefer you do it, but just keep in mind that as these numbers get larger and larger, it does sometimes get more and more difficult to simplify those fractions into simplest form, and this is a fairly easy, albeit time-consuming, way to do that. In this case, it is 4/5. Notice that my ratio does not have units. Make sure you make a note of this, star this, circle this, underline it. Make sure you're very, very aware of this. Ratios do not have units. So this is just 4/5. Now, here are 4 more examples. I'm going to recommend that you pause the video and try these on your own. I want you to give each ratio as a fraction in simplest form. When you're finished, go ahead and restart the video and see if what you have matches what I have. I'm going to assume you've already done that, and I'm going to go ahead and keep going. Notice I have 5 marbles out of 20 are blue. 5 marbles to 20 marbles is 5/20 or 1/4. 4 out of the 28 books are non-fiction. Well, that's 4 books compared to 28 books. 4 out of 28, which is 1/7. 45 out of every 100 pizzas are pepperoni. That's 45 pizzas to 100 pizzas, which is 9/20. And then you have 27 of the 33 questions are multiple choice. That's 27 questions out of a total of 33 questions. You end up with 9/11. How'd you do on that? Did that make sense? Certainly, if you had trouble with that, you're going to want to pause the video, go back and take a second look at that. More than likely, the error is a computation or calculation error. Those are easy enough to spot and fix. But if you're unsure as to how to set those ratios up as fractions, you may want to go back and rewatch the beginning of this video again. Now, here's something that's extremely important. Express the ratio between 3 quarts and 6 gallons as a fraction in simplest form. Express the ratio between 3 quarts and 6 gallons as a fraction in simplest form. So we set that up, 3 quarts to 6 gallons. But there is a problem. When we do ratios, it is very important for us to understand that a ratio must have like units. Quarts and gallons are not like units. This is not a ratio. This is actually a rate. A rate compares different units. But if I'm asked to put this as a ratio, I can't do that unless these units are the same. That means I have to take either my quarts and turn them into gallons, or I need to take my gallons and turn them into quarts. It doesn't really matter which of those you do. You should get the same final solution either way. In general, I find that most people find it easier to take large units and turn them into smaller units than the other way around, so that's the way I'm going to do this. I need to know how many gallons does it take to make a quart, or how many quarts does it take to make a gallon. Do you know that ratio or that relationship? Hopefully you learned in an earlier math class that 4 quarts and 1 gallon are the same thing. 4 quarts is equal to 1 gallon. This is one of the reasons why it's so important to have rates like this memorized. Because I can look at this now and I can convert these quarts into gallons, or I can convert these gallons into quarts. I find it easier to take each of my gallons and just multiply them by 4 to turn them into quarts. So this becomes 3 quarts on top, the same. 6 gallons is 24 quarts. Notice that now my units are the same. Since my units are the same, I can simplify this. Notice, by the way, 3 over 24, you probably can simplify mentally. If you wanted to write this out the long way, you could put these in an expanded set of primes. 1 times 3 is 3 because 3 is prime. 24 is just 2 times 2 times 2 times 8. Or 2 times 2 times 2 is 8 times the 3 is 24 quarts. And then you just go through and look for things that are alike. Turn them into ones. You get a 1 times 1 on top, and a 2 times 2 times 2 is 8 on the bottom. You end up with the ratio 1/8. That's not too bad, right? The important thing is we have to know what the relationship is between quarts and gallons in order to make that conversion. And number 2, we have to realize that the conversion needs to take place. Now here we're going to just give you a moment to try a couple of these on your own. I'd like you to try this first one, pause the video while doing that, then restart the video and see if what you have matches what I have. If you feel pretty confident in your answer, you can just skip ahead and see what my answer is without listening to my explanation, and certainly that will save you just a little bit of time. I'm going to assume you've already done that for this first one. Give 10 inches to 2 feet as a ratio in simplest form. Notice that my units are different. Inches and feet are not the same. There is a conversion for that. I either need to turn inches into feet or turn feet into inches. Most of the time it's easier to take the larger one and turn it into the smaller. And I happen to know that there are 12 inches in every foot. So if I convert those feet into inches, I get 10 inches matches to 24 inches, which then I would simplify to 5 inches over 12 inches. Notice that 10/24 simplifies to 5/12. Since the units are the same, I would say that the ratio in simplest form is 5/12. Here's another one for you. Give 5 centimeters to 75 meters as a ratio in simplest form. Again, pause the video, try this on your own, see if you can get it, and then restart the video to see if what you have matches what I have. If you feel pretty confident, you can certainly skim to the end of my explanation and just check the final answer. I set this up as 5 centimeters over 75 meters. I notice the units are not the same, and I'm going to take the meters and turn them to centimeters because I always like to take the big units and cut them into smaller pieces. I also happen to know that there are 100 centimeters in a meter, making this 5 centimeters over 7,500 centimeters. And since the units are the same, I'm going to go ahead and get rid of the units. This is 5 over 7,500, which is 1 over 1,500. The ratio in simplest form is 1 over 1,500. That's not awful, right? Not too bad? Tell you what, I want to make sure we understand the difference between what we've been discussing, ratios, and something we refer to as rates, because they are very similar. A rate is a comparison between two unlike quantities using division. Unlike quantities. So an example of a rate might be something like, if I wanted to compare 65 miles to 5 hours. I want to examine how far something can travel in a certain amount of time. I would not write this as a ratio, I would write it as a rate. 65 miles in 5 hours. 65 miles in 5 hours. And just like with a ratio, I'm always going to want to put that into simplest form. In this case, this is 13 miles in 1 hour. But notice these units are not the same. I have miles on top and I have hours on bottom. So ratios will not have units in your final answer, but rates will have units in your final answer. Check this one out. I could also do the rate 5 hours to travel 65 miles. Notice that I've taken these same pieces of information, but I've written them as a rate that's inverted. It's actually the reciprocal of the previous rate. Same numbers, just in different positions. I could have the rate 1 hour matches to 13 miles. Again, same information, different positions, depending on how I want to think about the problem. The units must stay, though. How about this one? $16 for 2 pounds of steak. That would be a rate. $16 compared to 2 pounds. Notice the units are not the same. Dollars on top, pounds on bottom. But I always want to give that in simplest form. $8 for 1 pound. Or I could give you the reciprocal of that. 2 pounds matches to $16. Or in simplest form, 1 pound matches to $8. Notice the fraction 2/16 simplifies to 1/8. But notice that I have to keep my units. Rates always have units because the units are not the same. They will not simplify away. Now, as a general rule, when we're talking about rates. Most of the time, if you have a problem with money in it, most of the time you're going to be putting the money on top. That's not to say the money will always be on top or the money has to be on top, but this way of writing it is much, much more common. And likewise, time usually goes on bottom. You are far more likely to need to use miles per hour than you are to use hours per mile. And we'll talk a little bit more about that as time comes on. Notice, again, both these ways of writing it are correct, but generally you're going to see money on top and time on bottom. Last thing we want to make sure we do is when a rate is simplified so that the denominator is a 1, we refer to this as a unit rate. Notice 13 miles compared to 1 hour. This is how many miles we can go in 1. My denominator is 1. How far we can go in 1 hour. So we call that a unit rate. And generally we will write it with the word per, P-E-R, instead of leaving it with the fraction bar. If I look down here, 1 hour per 13 miles, 1 hour per 13 miles, we would not leave this in this form. Instead, we would change this into 1 divided by 13 or 0.679 hours per mile. If it takes me 1 hour to go 13 miles, if I divide that hour by the 13, it tells me how many hours it takes me to go 1 mile. We like the word per for our unit rates. Same thing up here, $8 per 1 pound. We usually write with the word per. If I have 1 pound per $8, that would be 1/8 pounds per dollar, or if I divide that out, 1 divided by 8 becomes 0.2125 pounds per dollar. Notice this is per $1. It's called a unit rate. Now, we like unit rates because unit rates make it a lot easier for us to compare things. And we'll do a couple of those in just a second. Here's some more rates. I want you to try these on your own. Again, I would recommend doing them one at a time and then pausing the video in between each one as I explain them, just to make sure you understand. Again, generally we like to put money on top, and generally we like to put time on bottom. So try and be consistent when you're working your way through these so that it matches that convention. If I said $30 for 4 tickets, you would write that as the rate $30 over 4 tickets. Or in simplest form, you would say $15 per 2 tickets. Or if we wanted to do that as a unit rate, we would say 15 divided by 2 is $7.50 per ticket. Notice in all 3 instances, you have your units, you have your units, and you have your units. In my class, if you left off your units on a rate, I would tell you to do the entire assignment over again. So just be aware, it is very, very important to keep that in there. How about this? 14 minutes for 3.5 miles. Keeping in mind that we like to have time on bottom. I get 3.5 miles in 14 minutes. I went ahead and turned that into 1 mile for 14 minutes, for 4 minutes, sorry, 1 mile in 4 minutes. Both of these can be divided by 3.5. This one was just a little bit awkward. And then 1 divided by 4 is 0.25 miles per minute. Don't be overly frustrated if you had trouble getting this number from the 3.5 over 14. One thing that we do want to keep in mind is we don't like to have decimals inside a fraction. So if I were doing this, I would have doubled this to 7/28, 7 over 28, and then I would have simplified 7/28 into 1/4. Another way to do this is to multiply the numerator and the denominator by 10 and make this 35 over 140, which is also 1/4. How about this one? 20 minutes to type 440 words. That's 440 words in 20 minutes. Remember, we like to put time on the bottom. In simplest form, 440 and 20 simplifies to 22 words in 1 minute, or 22 words per minute. Last one, 1 million rotations in 15 minutes. That's 1 million rotations over 15 minutes. Both those look like they can be divided by 5. That's 200,000 rotations in 3 minutes. Notice I'm keeping my units. And then to put that as a unit rate, I would just divide 200,000 by 3. and get 66,666 and 2/3 rotations per minute. Now at this point, what I think I'm going to do is go ahead and cut this video off and split it into a two-part video. Make sure you check out the second part because there is a lot more useful information that you are going to need to know in part 2 of this video. As always, I do appreciate you taking the time to join us here today. Make sure that you ring that bell to turn on your notifications. Make sure you like and subscribe and leave us a comment in the comment section if you have the time to do that. As always, I do wish you the very, very best. You guys take care of yourselves, all right? Bye-bye.